And hi, I'm Steve from 1233D. Today we're going to bring you part 2 of the LDO 2.4 Revision D Voron build. First video you saw me do an unboxing to show the contents of the machine. This isn't going to be a full step-by-step build series. One, it would make for an extremely long video, but what we intend to do is explain how we've got to the points that we've got to, little things that might slip you up along the way, things to look out for, basically my tips to assemble this machine. The first part of the build is assembling the frame. This is one of the most important parts of building this machine. The reason for that, you need to ensure that the frame is absolutely square in all directions, because otherwise it's going to set you up for a bad time when you start to actually use the printer at the end. So, tips for assembling the frame. As you will see in the build documents, the frame is held together with blind screws. Now, basically what that means is you wind the screws into the ends of the extrusions, you leave the head out so far, you then slide over the extrusion and then tighten up through the hole. That locks the frame into place, basically. Now, the easiest way to do this is ensuring that you have a perfectly flat, doesn't have to be level, just perfectly flat surface to build your frame on. When you're laying the frame out, make sure you have all the correct parts, which are labelled in the documentation very clearly, and systematically work your way through the frame. What I found to be very, very useful was to ensure that all the edges were flush when I was assembling, because every extrusion was perfectly to length. So provided you make sure all your frames are flush to each other before you actually tighten them up, and then with the assistance of a large square, basically hold the square in the corner, check that you've got exactly 90 degrees to your extrusions, then tighten up. Follow that process all the way around until you end up with a cube. Once you have a cube, you then want to either get yourself a nice long steel rule or a tape measure, and then you are going to measure from corner to the opposing corner across the diagonal. You'll repeat that process then for the opposite corners. Provided your measurements read exactly the same, that will guarantee this segment of the frame is perfectly square. If it isn't, loosen your screws off, make any adjustments, tighten it back up, check it again. Do that for every side. Once you're happy that you have a perfectly square frame, you can then move forward. So the next steps, add the rails for the bed, the deck panels, really self-explanatory. These came in the panels kit, so you basically set out the bed rails at the given measurements, you fix those into place, you then flip the machine upside down or on its side, pop in the deck panel, make sure that you have it orientated the right way around with the hole in the back. Basically that's for your heater bed wires and whatever else to drop down. There is measurements to give you like the centers for these and all of that stuff. So again, just take your time with it. Make sure you follow each step meticulously and make sure all of your measurements correlate. Otherwise, if the bed rails aren't quite centered correctly and spaced correctly, your build plate won't fit and you'll have a knock-on effect. One thing I found, which I feel would be very worthy to point out, if you follow the actual Voron guide for the machine assembly, which you have to do, it takes you through all the steps that I've got to this point where we have assembled the frame, we've started adding the pulleys and whatever else, we've put the bed in, we've put our linear rails and bearings in place while I was waiting for a couple of parts to print that I'd actually missed. So I skipped to some electrics, and when I got to the electrics page on LDO's guide, I noticed that it asked me to fit this little Wago connection underneath the heat bed. So this now means I have to remove the heat bed to fit this so that I can wire the heat bed to this and then obviously route the cables back underneath. Now, if I hadn't skipped forward and done these two steps, I would have basically got through the whole machine, ran all the wiring, got the gantry in and everything else, and then realised actually these don't go through the panel. That would have just caused me a whole lot of trouble, because I would have had to then take out the heat bed, fit the Wago connectors and whatever else, refit it, and obviously with everything in this area it would have been a little bit of a nightmare job. Luckily I encountered it first. So before you fit the aluminium plate, fit the Wago connector. This is simply, if you're looking at the machine face on, it's on this rail, literally that connector fits under there on the rail. You secure it with 2 M5 T-nuts and 2 M5 10mm button head screws. Worth noting, before you fit that, get it plugged in and wired up. Doing that will just save you a whole lot of trouble and pain later on. Next thing, so I will spin the machine around a little bit. I then proceeded to use the tools that are in the print files to fit the linear rails. Now it's asking us to fit this rail with a clearance at the bottom. I think off the top of my head it was around about 3mm. This can be a bit of a tricky chore to measure and get accurate, so what I actually did is I simply printed a 3mm packer. Placed that on the frame, dropped my rail down to it, and then used the tool to centre the rail as I tightened up all the screws. Prior to fitting the rails, we did remove the carriages as shown on screen. So first things first, I am going to remove the little bunkie. I am then going to use this little magical block to slowly transfer the block onto that and put that little beastie somewhere safe, because I don't want lots of ball bearings everywhere. Some alcohol, don't drink it, you will go blind. Basically removing any dirt and grime from the rails. We have dirt. They might look clean, but they're not. Beautiful. We shall dispose of that, and I shall pop back in one rubber stopper. Put the lid back on my cleaner, get my little block, line it up carefully with the linear rail, slowly guide that back on, put on my overstopper. I now have a rail prepped, and what we want is, I'm just counting out, I want a hole, gonna miss a hole, another hole, and I miss a hole, just roughly line them up as you go, makes it a little bit easier. It can be fiddly to get it to locate in the channel, but then we have a hole empty on the end, which I don't like. For the sake of this, I will put another one in on the end. So we've basically got an extra one. The end one is doubled up. So if I then place that over there, we'll pop that out for now. Don't forget to put that back in. Take a little Allen key and basically just align all of those little T-nuts like so. Voila! Pop this back into the hole that hasn't got a T-nut under it, and with the special tools that we have printed in the tool section of the Voron build guide, we pop these over the rail to basically locate the linear rail on the actual extrusion. So next up we want a load of M3 8mm socket head screws, and then all I'm going to do is just put them in a couple of turns. That one I'll put just below the surface because I want to run that block over it, and if I don't, I won't be able to slide the block. Alrighty, we need to do a measurement. So this linear rail needs to be 25mm back from the edge. So all I'll do is get my ruler, line 25mm from the end, 25mm, and then just for peace of mind I will flip it, and we should have 25mm on the other end. And we do. With the little gizmo still in place, all I'm going to do is hold that, tighten down my screw, move it along to the next one, tighten down that screw, and just continue. Basically the purpose of this is I'm working from one end to the other. I don't want to start at one end, the opposite end, and get into the middle, because we could end up with a bend or a bow. Start tightening down at one end, work your way down the length of the linear rail, and this basically ensures that that rail is perfectly parallel to the extrusion, which will be critical when it comes to making sure that everything that you have assembled so far is square and true. The squarer and truer we can get this, the better the machine will perform in terms of accuracy, speed, less vibrations, all of that kind of fun stuff. Voila! Leave these in. Do not take them off yet, because you do not want this block to go whoosh off the rail. But that's running nicely. We haven't lubricated these up yet. We will lubricate them when it comes to getting everything assembled together. Very simple to do. You have a little tiny hole on both sides, and all you do with that is you inject grease directly into the carriage. You then proceed to move the bearing, wipe off any excess grease from the rail. You're golden. And basically that showed you how to remove the carriage without the bearings flying everywhere. We then cleaned the rail with some IPA alcohol, make sure it's nice and clean, got rid of all the muck and grime that was on there. Even though they looked incredibly clean when we unpackaged them, you'd be surprised how much dirt actually comes off them. These are now ready to grease. We haven't done that yet, and I will talk you through the process for that and how easy it is to do that. So we fitted all 4 of those, we fitted the bed, we've then fitted the pulleys at the top of the frame. On top of that, we have fitted the motors to the base with the pulleys, the feet, and a few other bits and pieces. We also started to assemble the actual gantry. Quite a few parts in this process. It's really self-explanatory when you're actually following through the guide. Everything fitted together absolutely perfectly. I used the tools again to make sure that I had the pulleys for the motors set correctly and orientated the correct way. Just take your time when you're looking at the actual diagrams, because some of these parts are handed, so one motor is set up slightly different to the other to allow your belts and everything run in the correct orientation. The only thing that is different on this actual gantry that is not in the kit is we have opted to basically replace the clicky probe that's situated at the back of the machine for a tap. And the reason for that is I just think this is a lot better system. So that is literally the only difference. Other than that, on this rail here, all you would see is a bearing block carriage. So this is basically where we're up to with that. We will tip the machine up and I will show you up to underneath. So we've started running the electrics. These 2 DIN rails are included in the kit. Again, the measurements are given. Relatively simple. So under here, I have firstly fitted the Leviathan board. I fitted the pie to the board. I fitted the bracket to the back of the board that actually clips and locks it into place on the DIN rail. Once I got that in place, I then fitted the power supply. I fitted the solid state relay. Basically, I got the main components in place and then started to systematically wire everything up. So I labelled my stepper motors with the little tags. I routed the wire in. I put those into the corresponding sockets on the board. I then started to run the power to the correct places on the board. From the Nighthawk board, I've put power to that. Basically now all we need to do from that is put the USB from there to the Pi. The Raspberry Pi is literally powered directly from the main board via this little jumper, which you get 2 in the kit. There's one for a Raspberry Pi 3 or 4 and one for a Pi 5. The pinout on the Pi 5 is different to the pinouts on the 3 and the 4. So they are labelled specifically. Make sure that you select the right one, because otherwise you're basically cross polarity. Your Pi will go up in smoke. Nobody likes a smoky Pi. The kit also comes with a USB, which you can use this USB that's supplied, or there is like a little ribbon cable type USB. I opted for this one because it just lined up better and I thought it was going to be a little bit more durable. Everything wiring wise is really well labelled. The only thing you have to do with the wires, in the motion pack in the kit, they give you a little bag with the actual yellow tags on. In the drawing they have shown these to be down here, labelling, but to me it makes more sense to have them at this end because I can actually verify which motor's for which and then look at the corresponding socket, because they are labelled on the plugs which motor should be where. So if you have a faulty connection on Z3, you can look down to Z3, you can unplug it, you can check for continuity, whatever else. That was the way I chose to do it. Obviously, if you want to have them here, put them there, that's fine. Apart from really the Wago connector under the bed, I haven't encountered anything that seriously tripped me up. It's just a case of like studying the manual. Even if you look a couple of pages further forward to see what the next steps are, to make sure that everything you're doing in the previous step is going to correlate with the second step. Take it stage by stage, like this part here. This I treated as a totally separate project from assembling that, because there's quite a few moving parts and the orientation of certain pieces and whatever else. There's like, for instance, you can clearly see this printed part is different from this printed part, and it does matter which way round they go. So just take your time. So provided you go with the LDO wiring guide, you really can't go wrong. Take your time, read everything, check it, read it again before you make your connection. And then once you've done it, compare that to the actual diagram so that you're absolutely confident that you've got everything at this point correct. So really, we are at the point where we are going to be mounting the gantry into the frame, attaching the belts, and yeah, we'll be moving forward. I shall tip that back up. So the plan is, in the next video, which will be part 3 of this series, we will basically get the machine up to the point where all the mechanical aspects of the machine are done, ready to proceed to the next step, which will be part 4, where we complete the wiring, do the firmware clipper and set up the config files and everything else, and hopefully, all being well, run our first print. So please do not forget to like and subscribe. If you do have any questions regarding this machine or anything else on our website, drop them in the comments below. We do stock the 2.4 and the Trident machine, along with kits and accessories and parts and everything else. See everything in the link in the description. Don't forget to like, subscribe, share, and we will see you on the next one. Bye-bye for now.
As always, we aim to have the most competitive 3D printer prices on the market. If you see any of our printers being sold by a mainstream retailer for less, please drop us an email using the link in the description, and we'll do our very best to beat their price. Also, if you're watching from outside the UK, check the description for links to our European 123 3D sister stores.